Thank you for the introduction, Lucas. So today's talk is on reusing breach data for attack and defense. Now, as a pen tester, I'm of course coming at this from an offensive standpoint, but I think there's still a lot of value to be considered in how this can be employed defensively, not only in terms of user awareness, but also structuring how we deal with threats. I think one of the things we typically find in cybersecurity is, and I'm seeing this a lot in the last 12 to 24 months, we have this obsession with all these fantastic technical stacks without understanding the why we're doing this or why we're taking certain actions because a specific standard stipulated what we're going to be doing. So today I'll go through a bit of what a breach actually is and what it means for us, some of the considerations around breach data, as well as its application for when we conduct penetration testing amongst my team, and what do we do off the back of some of the breach data that we see out there and what it means for us. So a bit about myself. I've been pen testing now for 10 years. I've been running my own practice since February 2015, and I'd still learn new things. So for me, getting my head around breach data and understanding what it is and what its risks are, I think was really something that hit me personally, and you'll see it a little bit later on here. It kind of hit us off, well, wait, this is a risk for me. Surely it's a risk for a lot of other companies out there. So I come back to what's really been driving this talk. One is our own experience in pen testing and where penetration testing is evolving to, personal observations with passwords, and also, as I said before, I think what is absent in a lot of the discussion around cybersecurity is a bit of the why. On top of this, we are now seeing an evolution away from internally hosted services to software as a service to different means of authenticating to those services and understanding what the risks of some of those are. So before we really start going into the, hey, here's how we were able to compromise places with existing passwords, I think it's important to understand what a breach actually is. So this is where there's an incident where sensitive, protected, or confidential data is being viewed, stolen by an individual who isn't allowed to view it. So we always talk about this whole thing of, well, PII, it's all got to be confidential and it has to be kept secret. But what happens when that data is stolen, and how can that data be reused? I think there's often a lot of fanciful ideas of how that data can be reused. Some of it's a little far-fetched. Some of it's actually quite practical and, of course, quite specific depending on how we've evaluated certain end-to-end cases. In terms of data breaches and a bit of history, if you want to pull up a far more detailed image of all the breaches, this site information is beautiful. Illustrates a chronological timeline of breaches, their size, their impact, and what they meant. Feel free to grab the QR code. It's a little bit more trustworthy than a USB key at a security conference, I assure you. No? Okay. But one of the things we've seen, if you have a look at the image on screen there, is perhaps in the last 3 to 5 years, the sheer size of breaches and their count has increased exponentially from what you were seeing back in 2005 with some fairly low-key breaches and events that had happened. Significant ones you can see there. Yahoo twice, eBay, LinkedIn, Target, there's a couple there. So what's some of the data that we actually extract from breaches, or what gets extracted typically? Email addresses and other contact information. Email addresses are important if you like spamming people with updated privacy terms or other marketing material. Home address and contact details are also significant that we can correlate with trying to work out who an individual is and understand a little bit about them. We used to see a lot of credit card data, and this is something that if we look in a lot of recent breaches, thankfully with everyone starting to really be conscious of PCI DSS and the impact of credit card of breaches involving credit card data. We're starting to see a lot less by way of security breaches involving cardholder information. Passwords is always a lot of fun, and that's really what the crux of this talk is being able to identify passwords in order to achieve access into other environments or organisations. Correspondence, so the more significant one of those was the DNC breach during the US election, as well as some of the activities WikiLeaks has been undertaking. And every now and then we'll see things like scanned IDs, IP addresses, context-specific material. So one of the things that I liked doing with with the breach data from an adult website was correlating the IP address with government departments and then dates of birth of known or prominent politicians. You'd be surprised how many names you can actually start pulling out there. And this was probably the first interaction here on I had with doing data breach correlation and understanding what was taking place. So 2013, someone from Anonymous decided to pop a box in the ABC and dump usernames and passwords. What was peculiar about this one was that it looked like some bloke on a Russian underground forum beat them to it long before that. Other things I've liked doing with some of this breach data as well, Ashley Madison is correlating specific postcodes with bots and being able to identify a positive correlation between suburbs with wealth and those suburbs with wealth and bots, where, say, for example, the Lower North Shore in Sydney will have a lot more automated accounts on the female side than, say, if you were to go to Southwest Sydney. And LinkedIn, I mean, for us and for my team and I, the breach data from LinkedIn has been phenomenal when it comes to conducting targeted attacks on companies. So that being said, probably one of the more significant breaches that we saw out there was the breach around Stratfor, which I think highlighted not only the individuals that were making use of that information, but the intelligence generated by Stratfor, but also some of the credentials they used, as well as the credit card data as well. The Yahoo breach is fairly large, but in our experience, we haven't really been employing the contents of that breach to the same level as we have with LinkedIn, mostly because we're dealing with companies and not individuals. And of course, the most menacing one has been adult websites. More so, and I wrote about this in 2015, specifically with the Ashley Madison breach, and when the breach eventually did get disclosed, what was peculiar was there was something in the order of 1,300 defence.gov.au accounts. Now you think about it, if you were to blackmail an individual with one of those accounts who happened to be married at the time, who also held a high-level security clearance, that information could actually be quite easily used against them to elicit information that would be of great value. So this is my interest. This is my password from LinkedIn that I was using in 2012. Needless to say, that password as of 2016 was still in use on 5 just random websites that I was using for personal means. Thankfully, nothing by way of corporate environments. That was my password. Of course, it met the ISM requirements of a capital letter, a couple of other letters, a few numbers, a certain length. But at the end of the day, it was disclosed and readily available for an extended period of time where there's a good chance someone may have been able to reuse it. This is a screenshot from our public database, from our private database. I'm not publishing this, where we maintain this all of this data that we subsequently use in penetration tests. So I'll post this question, and feel free to put your hand up if you fall into this category. Who here forgets to change their password on a website, or rotate passwords every couple of months, or holds the exact same password because it's easy to remember across, say, 2 or 3 dozen sites because you now have to create an account for everything you use. Anyone? Yep.
I don't forget. I deliberately don't.
Is it written on a secure yellow sticky note?
No, it's held in a password note.
Spot on. Other elements we have as well is, so for example, when we identify proxy servers and the outgoing IP address of that, we can start using that data to identify individual accounts, individual users, or user behaviours based on that data that we've been able to identify. Other things we see as well, if we're doing really targeted attacks on executives, is one of the things we start looking at is behaviours or patterns that exist in passwords. So this individual specifically is a very prominent individual whose password contained the word bounty, which may or may not have something to do with the story of HMS Bounty, where a young lieutenant decided to overthrow their over-authoritative captain. Other aspects of this as well are, what sort of patterns are individuals doing with their password rotation. Also, a curious factor is, for some of our clients, is there any opportunity for blackmail or espionage or financial gain based on systems that other individuals are using that we've been able to identify off the back of the information that we've been able to acquire? So what about the information that my team and I are maintaining? So we now have something in the order of about 20 different sets of breach data that we've been able to acquire over the last 12 to 24 months that we now maintain in a database that we consistently use when a pen test demands it. So I'm not a lawyer, and I'm pretty sure maintaining stolen data falls into this grey area, but one of the things that sort of interests me in this space is, okay, we've got access to stolen information that's readily available somewhere in the public or somewhere in Tor. It's been disclosed, it's a known fact. Is there any value in having legislation or having laws that prevent us from accessing that information to be using in a defensive manner? I know Troy Hunt, for example, doesn't maintain passwords to get around that, but for us, maintaining passwords is important just because it allows us to identify what the actual risk is to a lot of our companies that we work for. I also question, how does that differ from, if you have a look at, say, MS-1710, which was an exploit that was stolen from the NSA and then openly published? How does it differentiate from that standpoint? So if you think about it, the exploit code's been made publicly available, even though it's been stolen. We can use that to better articulate risks to companies and to individuals to say, hey, this is why you should be patching. Similarly, this is why you should be changing your password, because you've actually kept the same password for the last 5 or 10 years. And this will always fall back to intent. Our intention is to enhance the security posture of our client companies. That is why we use this information, and if we take that ethical stance on it, that is, at the end of the day, there shouldn't really be any issue around ethics of why we maintain this sort of information. So already this year, and even probably as early as March 2017, we've already been seeing large-scale credential stuffing attacks with breach data. Talking with Sam Crowther at Casada, he runs a company that provides protection against automated attacks. One of the things that he said was, hey, look, Ed, we're seeing all these cases where people are using very precise usernames and passwords to attack some of our client systems. Do you have any thoughts on it? And so some of the information that they were capturing off their clients or off their prospective clients was indicative, was in fact data from the LinkedIn breach. And they were saying that they were seeing this as a regular occurrence every few months, where someone would conduct an opportunistic attack against a few specific sites. So how are we using this in our current role as pen testers? So firstly, one of the things we have to do is plan and execute our engagement. And this starts off with a really detailed reconnaissance activity to understand what our company looks like and what the business we're attacking looks like. This here is what I refer to as asset enumeration. Just to check, who here acquires pen testing services regularly? Yeah. So one of the things I get quite irritated about is when someone says, oh, well, we only need these IP addresses, pen testers. Well, no, this is actually what you look like. It's not IP addresses, it's not specific host names. This is the entire breadth of your business. And so one of the value propositions we have with our team is we map out and we understand exactly what your organisation looks like from an internet-facing standpoint. It's not just about IP addresses, it's about an array of services that either your staff or other components of your organisation are using. And this will vary from individual web applications that are outside of your control to other cloud-based assets, even your individual network infrastructure, and even things that individuals own or maintain themselves. And of course, this all comes back to who are the users within your environment, and this is what we need to understand next when we're starting to tie in breach data with our attack sequence. We need to understand who those staff members are. We need to be able to identify any prior accounts that we can correlate with. So for example, most people are using either a Yahoo or Gmail account with their LinkedIn account. We need to be able to extract that actual email address. Other domains as well. In some cases, some organisations will have multiple domains. We then need to enumerate users within those domains. Third-party suppliers as well. So for example, if you have another organisation that logs into your infrastructure as well, who are they and what are some of the risks associated with that? And generally speaking, we can map out a lot of this information without having too much detail from our target client. So this is an example of what an attack surface might look like. As I said before, it's not just about what's within your own control. If we have a look at it, we have a number of as-a-service platforms. So if you have a look at WHOIS entries for individual company domains, places we're using, some of our target companies will be using things like Crazy Domains. They'll be using other domain service providers. Someone else will have an account registered to that. We also see a lot of people adopting other as-a-service platforms, so things like Insightly or Zoho for CRM activities, Xero to manage their own bank accounts, AWS infrastructure. If there's a social media presence or an active social media account, someone will be registered on Twitter, LinkedIn, Instagram. There's surprisingly a lot of these service platforms that have that value proposition of, well, we're managing the entire environment, and we're also pen testing it, say, through bug bounty programs, or we're actually spending a lot of money on the security aspect. But then there's the individual use component of, well, I've just registered with a username and password, which is the same one I've been using for the last 10 years. Then, of course, you have all your internal infrastructure. Individual and personal accounts are an interesting space. We don't target those just because that's your own personal stuff, and that's outside of our scope. And then if you ever get onto the internal network, there's going to be other applications or services around the place that you can target. So we've got all this information. We've mapped out the organisation we're going to be targeting. What's next? So typically speaking, usernames will be something along the lines of an email address, or first initial last name, or first name dot last name, or underscore, or the first 7 characters. We'll have to understand what that username variance looks like. And then off the back of that, we'll start enumerating through the known passwords. If there's any numerical incrementing or any default values that we become cognizant of, we'll start targeting those. And we typically have at least some level of semi-automation around this. Generally speaking, I typically find that relying on a purely automated attack is ineffective, either because there's some sort of anti-automation protection within a web application, or because it requires a little bit of human analysis just to understand how things are shaped. So we'll shape the attack based on what we understand when we're looking at our target for testing. So once we're in, and once we've gained access to one of these organisations or a web application or an as-a-service platform, what happens then? Well, let's start finding some information. Let's start mapping out what this organisation's about. Let's see what we can identify that we can reuse at a later date, or let's see if there's a means of post-exploitation. I'll explain one of those cases shortly. Pillaging data is always fun. Customer lists, existing emails, or invoicing or financial details are always interesting. Follow-on social engineering attacks are always a lot of fun. So if you were to gain access to the to Office 365, the assumption is that if you're in that environment and you've either got Mimecast or you've got some sort of email security in place to prevent phishing attacks, the assumption is that that internal environment is secure. So if all of a sudden Bill is sending emails to the CEO of, hey, boss, can you go to this URL to reset your password? It's actually quite convincing because it's all occurred from within the internal environment. And this kind of leads to that assumed levels of trust. That environment is trusted because X. And over an extended period of time, you can remain in those places because no one's resetting their password, no one's doing any monitoring, no one really cares about what's occurring at that point in time. So how does this look like in the real world? Within our own team, since we started through till about February of this year, we've done about 137 penetration tests, and those vary from web applications to specific design and architecture reviews to a number of engagements. But 29 of these are what we classify as whole of organisation pen tests, i.e. You are the business is the target, we're going after you. And off the back of this, we've identified 19 instances of credential reuse. And that's usually either someone on this remote web application that people have forgotten about, just simply has forgotten to change their password. Or we start seeing systemic instances of this where we actually see consistently users are not keeping their passwords modified, or users are not modifying their passwords consistently. Now, in 3 cases, we actually identified that these were the domain credentials that we were able to compromise. I'll talk through one of those scenarios shortly. But what makes it successful for us as pen testers, because there's no centralized means of authentication, no password management, this is usually what allows us to be successful more than anything else. My favorite one, which was a test I'll mention shortly, was there was a requirement to reset passwords every 90 days. That requirement did not apply to the IT team. So I'll talk about it shortly. Other things as well, user behaviour, so passwords such as summer 17 or autumn 14 or whatever starts to suggest to us that behaviour of this user's not updating their password. Large attack surfaces through this as-a-service model is also quite interesting in that if a company is using 5 or 7 different platforms and they're not having that centralised authentication management, the ability for those individuals to maintain credentials properly becomes extremely limited. Perhaps the strongest factor in preventing us from gaining access has been around 2-factor authentication. We're not going to beat that unless we beat you over the head and get your phone. Every now and then we typically find a reduced user base is also a contributory factor. So the more users within an organisation, the more likely we're going to be able to get access. And also if people are just using Active Directory as the means for acquiring username and password or other forms, once again, it's going to be a little bit more harder. But at the end of the day, whilst the statistic of almost 2/3 of the companies we've tested we've been able to successfully breach off the back of this information. A lot of it I evaluate is really down to chance. So this was a pen test we had in late 2016. We identified 40 accounts associated with this organisation, and then we just decided to test everyone's username and password. So we got access to Outlook Web Access for the IT manager. Off the back of this, we were then like, okay, we've got pretty much access to wherever we want to go. What do we want to do next? So the challenge with this one and what was asked of us was, all right, let's see if you can get the CEO's email, CEO's password. So we then said, hey, CEO, can you please log into this Jira site? Yeah, we got his password off the back of this. And it's peculiar that whilst this organisation had made a sizable investment in all these defensive technologies, we were able to just bypass them with this one little issue they had with their passwords. Zoho is very interesting for us. In fact, this has probably been one of the most successful attacks we've always done, has been Zoho as a CRM isn't particularly well locked down. Funnily enough, salespeople, actually, do we have any sales folk in here? Nope. A lot of salespeople I tend to find will gravitate towards their CRM as their source of knowledge. And so if they're still reusing the same password they've had from the last 3 or 4 companies that they've worked for, they're going to reuse their password here, and you're going to be able to get in. So this is not the person we targeted. I was trying to find a screenshot I could use for this, but this was about as good as we got. So I've just copied this from their brochure site. But if you have a look at the contents of a lot of CRMs, you get things such as customer details, dial-in details, passwords, credentials. The volume of information that can be reused from a threat actor standpoint is massive. But what's peculiar though, and the one that really struck me, was a forensics investigation we had in August of last year, where we had an Australian company that was using a US supplier. The US supplier was on Office 365. One of the individuals within that organisation, namely the accounts payable person, was still reusing their same password from the LinkedIn breach. So we were able to identify, hey, look, you've actually suffered a credential stuffing attack, and there was what I would refer to as an operationally sophisticated attack against that one individual to extract something to the effect of $250,000 from this Australian company just through a bit of social engineering via email. And it's funny, there's no sophisticated exploitation here. There's no having to write code. It's a case that these guys just simply found an account who had reused their username and password, a bit of social engineering, and then payment made to a bank in Hong Kong that was then moved onwards in the space of about 2 weeks. And it was interesting going through some of the old emails on this one of just how, if you went to this morning's keynote, just how these guys were able to coerce the behaviour from the Australian organisation to not only make the payment but convince them that it had been made and that no one else had actually picked up on this from the other organisation. Just checking who here uses Office 365. Keep your hands up if you have two-factor authentication enabled. About half of them, half don't know. Yeah, it's been a difficulty we've had with a lot of our Office 365 clients. A lot of them don't understand or don't know how to enable two-factor auth, and it's a bit of a workaround I've found when talking through those clients. But no one's doing 2FA on Office 365. And funnily enough, we just had last month a social engineering attack that hit an Office 365 account that resulted in the loss of about $80,000. So 2FA. If there's nothing else you take away from this talk, 2FA, 2FA, 2FA. So on with the theme of the conference, building resilience. How do we take all this information and how do we start shaping the defence? Show people what's out there. if you saw your password, like you saw my password there before, if you saw that up on screen, what do you think your reaction would be? Anyone? Change it? Who here would be panicked? And who here would be thinking, all right, how do I do this security thing? Security's hard. If you can actually show this to your end users of, guys, look, this is the passwords that we know about you, you start to elicit that behavior from that individual of, all right, I actually better start thinking about what I'm doing in the digital world. So one other thing that we are now looking at is how do we incorporate this data into enrollment for organisations? So with a lot of our customers, we're now providing this information to them when a new user comes on board of here's some information about a user that you're just about to bring on into the business. Are they aware that they should not be using this password when they join the organisation? You start to coerce individuals into acting in a far more secure behaviour. YubiKeys, two-factor auth, other second-factor authentication mechanisms, always valuable. Can't go wrong there. Except maybe when it takes you about 15 times to implement it properly. Having centralised control of authentication and access is also important. So my team and I, a lot of our businesses run using Google for mail and documents, and a whole heap of other services that we tie in with our Google service for authentication and access management. Identifying and understanding your environment, your applications, and the attack surface is also critical as well. The reason why a lot of attacks are successful, and we had this with one of our pen tests about 2 weeks ago, was everyone completely forgot about this one application that was off to the side that no one had really maintained in the last 5 or 10 years. And we were able to get SQL injection in the space of about 30 seconds and got everyone's username and password, and funnily enough, no one had changed it in the corporate environment. Unless you actually have a pen testing organisation that's conducted detailed reconnaissance before scoping and before execution, you're not really spending your money wisely there. So take the time to understand where all your assets are in the business, including your digital assets and your people as well. Some other defensive practices with breach data as well is also understanding where IP is also understanding where users are going to, being able to map out individual behaviours, and use that to start shaping any follow-on defensive actions. That will really start to vary on a case-by-case basis. But I mean, in one case we had with a customer, the IP address from where they were proxying from, the IP address where all their traffic out to the internet was originating from, had not only disclosed things such as the services they were accessing, but where they were originating from, as well as the fact that they hadn't patched Chrome in about 2 or 3 years. So using that sort of information that's disclosed to shape defence is also quite important. That's my talk. If you want, feel free to email the team and I. I've also got a link there to our website if you can trust QR codes again. I'll open up the floor for questions.
Thanks, Ed. Thank you very much, guys. So we do have one question via the CERT2018 app. So if you do have any more questions, you can still pop them up, and I'll see them pop up. If not, I'll quickly run around with the microphone. So the question is from Martin, who says, is text, like as in TXT, SMS, still a second factor?
Look, I think it's the second slowest person in Jurassic Park. I think that's probably the best analogy I can have for that one. It's a level up from some of the existing, from having no two-factor authentication. But there's other risks within there, such as is an individual's mobile phone adequately protected? Is the path to that phone also adequately protected as well? So, you know what? It's better than nothing, but there are other options out there, and I think that will really depend on what people are willing to spend on for security.
Yeah, and there are known attacks against SMSs, and
Yeah.
I think NIST deprecated it as a recommendation as well. So
they have, but
yeah.
it comes back to it's better than nothing.
Yeah, exactly. It's second slowest part. The second slowest person in Jurassic Park. It's a great way to put it. Were there any questions while I got the microphone? No? Alrighty. Well, if we can give Ed a round of applause. I think that was a great presentation. Thanks, Ed.